let's talk about the parasympathetic nervous system. What is the opposite of this? We seem to know this all too well. We don't seem to know really enough about this. And actually, we have a lot more control over this than we have over this. We don't really have any control over this, but we have a little more control over the system right here. So, while we are relaxing and resting and digesting, what can we expect from these organ systems? One of the effects of the parasympathetic nervous system, or parasympathetic tone, is to decrease heart rate. And this system uses acetylcholine, and so you'll hear this referred to as the cholinergic system. You'll notice while you're resting and taking it easy, maybe you'll hear your gastrointestinal tract make more noise as it starts spending more energy to move food around. You didn't really need that to move food around while you were running away from the woolly beast, but now that you're relaxed and taking it easy, you can expend the energy on digestion. Something else that goes on with this system is it closes lung airways. Your rest and digest system will close airways and increase secretions in the lungs with the thought that it's going to do a better job filtering the air, giving us better air to breathe. The most important thing you can remember about the parasympathetic nervous system is it uses the neurotransmitter acetylcholine. And the receptors on the organs that sense the acetylcholine coming from the parasympathetic neurons, those receptors are called muscarinic receptors. One of the nerves that controls the heart and the lungs and the gastrointestinal tract, that's called the vagus nerve. The vagus nerve is a parasympathetic nerve, and the vagus nerve uses acetylcholine to slow down heart rate, close lung airways, increase secretions, and speed up digestion. So, cholinergic agonism is the same thing as cholinomimetic, which is the same thing as parasympathomimetic. And the first parasympathomimetic cholinergic drug we will talk about is bethanechol, urocholine. It is a cholinergic muscarinic agonist. So you'll hear bethanechol referred to as a cholinergic drug. You'll hear bethanechol referred to as a muscarinic drug. You'll hear bethanechol referred to as a parasympathomimetic. So cholinergic, muscarinic, and parasympathomimetic all mean the same thing. They're all the same drug class. And so this bethanechol, because it mimics the effects of acetylcholine, can be used to stimulate not only the bowels, but bladder function as well. We talked about acetylcholinesterase being the enzyme that breaks down acetylcholine. So if we block acetylcholinesterase using drugs called cholinesterase inhibitors, then we end up with more acetylcholine indirectly. So cholinesterase inhibitors are referred to as indirect cholinergic agonists. Still, they're considered cholinergic drugs. They're considered parasympathomimetic. So one of the most important things you can remember from this lecture is cholinesterase inhibitors are cholinomimetic because blocking the breakdown of acetylcholine increases acetylcholine levels, so cholinesterase inhibitors are cholinomimetic. Can you see how bethanechol, urocholine, will close lung airways and can cause bronchospasm and make asthma worse? That's why it says avoid in asthmatics and people with lung disease. So cholinesterase inhibitors are referred to as indirect cholinergic agonists. Can you see how cholinesterase inhibitors will close lung airways and can cause bronchospasm